What's up guys? In this video I want to show you guys how to derive the product rule formula. So I'll write it in a bit of a different way just because I prefer it that way. I prefer writing the product rule as if f at x equal to g of x, h of x, which means it's the product of two functions, then f prime x, which is the derivative of basically this, must be equal to g of x times h prime x plus h of x times g prime x. So in this video I'll be showing you guys how to get to this formula. So how you get to this formula is you start by saying, basically, if you have f at x as g of x times h of x and you want to find the derivative, oh, by the way, we'll be using first principles. If you want to find the derivative of f at x from first principles, you do the first principle formula, which is limit as delta x approaches 0 of what? Of f at x plus delta x minus f at x all divided by delta x. Okay, so now what I want us to do is I want us to find out what f at x plus delta x is. F at x is g of x, h of x, right? So if f of x is equal to this, that means f at x plus delta x must be equal to, you put the plus delta x in the place of x, right? So you just do the same thing on this side too, because these are two functions, and if you are changing the input here, you must change the input this side too. Okay, so say g of x plus delta x, h of x plus delta x. That's basically what f at x plus delta x is equal to. Now let's go into plugging that into this and plugging that into this, because this is f at x plus delta x. So we say f prime x is equal to the limit as delta x approaches 0 of f at x plus delta x is this, so we say g of x plus delta x, h of x plus delta x, and we subtract f at x. We know that, I'm sorry about the concentration of the camera, I don't know what's happening today. F at x is g of x, h of x, and then we divide by delta x. Okay, now I want us to do something. This is what we have so far, and from first glance it looks like there's nothing we can do to it. X plus delta x, h of x plus delta x. Now what I want us to do is something that has been explored in university mathematics. Ever since we started, there's this thing we keep exploring, which is adding something to force the equation to be what you want, and then subtracting it to cancel out the effect. We do this when we complete the square. You know how when you complete the square, you say you add half the coefficient of the middle term squared, and then you subtract that. And also we also do this in trigonometry when we are trying to reverse something to have some multiples of theta. So here what we will do is we will add something and subtract it. What are we going to add? We are going to add g of x, h of x plus delta x. Right, this works if you say you're adding h of x, g of x plus delta x2. The important thing is that you use two different functions, and one of them has to be x plus delta x and the other has to be just x. Since we added this, we have to subtract it again. So we're subtracting g of x, h of x plus delta x. And then we bring that back, which is g of x, h of x, all divided by delta x. Okay, so what I want from this is I want to take out a common factor, but there's something I'll do first again. What I'll do is I'll take this and bring it closer to this, and I'll take this and bring it closer to that. You will see as time goes on why I did that, but let us do so. So we have f prime x is equal to the limit as delta x approaches 0 of, I'll take this closer to this, which is g of x plus delta x, h of x plus delta x, and then you say minus g of x, h of x plus delta x. You will see the reason why I'm bringing it this side pretty soon. X, h of x plus delta x minus g of x, h of x. Right, I rewrote every other thing exactly like it is, and then divide by d of x, dx, delta x. Right? Now f prime x is equal to the limit. Now what you'll do here is very interesting. It's very interesting. This is what you'll do. I want you to understand first that this is the same as this, right? We subtracted this and added it, so that doesn't do anything. So you have to understand that. Now, when we come to this part, we say we take out h of x here, h of x plus delta x as a common factor. This will be very, very interesting. Okay, I'm sorry for I have to emphasize it, though it's very interesting. If you take out h of x as a common factor, you will have in brackets g of x plus delta x minus g of x, right? Right. And then this side, you will take out g of x as a common factor. So you have a plus there. You take out g of x as a common factor. You have h of x plus delta x minus h of x. There's something that begins to reveal itself as we get to here. We have x plus delta x, so it's g of x plus delta x minus g of x. This side we have h of x plus delta x minus h of x. And on the denominator we have delta x. Since we have a positive here, I want us to distribute the delta x, just like how we distribute the exponent, the denominator normally. So the denominator is going to go with this power, this guy, and it's also going to go with this guy. So you have delta x there, have delta x there. To prove that this is the same as that, if you take the same denominator, since it's the same denominator, and add the numerators, you still get that. Now f prime of x is still equal to the limit, but now we are going to do something again, which is we'll say it's equal to the limit that delta x approaches 0 of h of x plus delta x. Now I want you to isolate these guys, so write them like this: g of x plus delta x minus g of x divided by delta x plus, we're still finding the limit of all of this, g of x, the same thing you did here, you're doing there. So you're isolating these guys now. You have h of x plus delta x minus h of x, all divided by delta x. And you have f prime x. Now what are you going to do? You are going to distribute the limit sign. Remember, according to the laws of limits, you can take this limit and put it here, and then distribute it to there, and distribute it to there, and distribute it to there. That's the laws of limits, right? Don't mix the laws of limits with the rules of differentiation. So we are using the laws of limits here. So the laws of limits allow us to say we are taking the limit as delta x approaches 0 of h of x plus delta x, right? That's our first limit. And we can take this with that. We can say, and times the limit of delta x is times the limit as delta x approaches 0 of g of x plus delta x minus g of x, all divided by delta x. And then we go to this side. Since we already distributed the limit here, we have to distribute it to this side as well, which means we're going to have plus the limit of g of x as delta x approaches 0 multiplied by the limit as delta x approaches 0 of h of x plus delta x minus h of x, all divided by delta x. Okay, I hope you understood that. The limit sign was basically distributed to this, 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 and this, because taking the limit of a sum is the same as taking the sum of the limits. So that explains why we could take this to there and there. And taking the limit of a product is the same as taking the product of the limit, which explains this. Now we say f at x, or f prime x, sorry, is equal to. This is the final step, which has the most revolutions. We basically substitute delta x is equal to 0 where we can. So if you sub delta x is equal to 0, because, okay, let me make a better explanation for this. If delta x is approaching 0 and we just have h of x, then the difference is approaching, this is approaching 0, which means it's the same as if this is not there, because it's so small that it has no effect on h of x. So you just have h of x, right? For this one, we are saying the limit as delta x approaches 0 of g of x plus delta x minus g of x divided by delta x. This should look very familiar to you, because this is the same as this. It's just that you're using g now. So if this is g, if this was to change and be g, that would mean this would be g prime x, right? That would be g prime x. So this is just g prime x. That's the simplest explanation. That's the simplest. But the longer one, you might say, one of the longer ones, you might say, you are saying taking the difference in the values of g from where g is x to where g is x plus delta x as delta x approaches 0. So that means you're finding the slope of this function g, where the difference or the distance between the consecutive terms or consecutive points you are using is getting infinitely slow, because about small as it approaches 0. And that is the definition of a tangent. That is a definition of a derivative, sorry, of a derivative. So this is the derivative of g. This limit is the derivative of g. This one. So this is g prime x plus this. If delta x approaches 0, g of x is not affected because there's no delta x in here. So we still have g of x. And then this, the explanation is exactly the same as this one. So this is the derivative of h of x, because this is h of x plus delta x minus h of x, which means this is the derivative of h of x. So it's h prime x. And that is your product rule, as stated at the top. It says f prime x is equal to h of x times g prime x plus g of x times h prime x. So I started with the g this side, but it's the same thing. That's your product rule. Thank you for watching.